Okay. Good evening, everyone. I'm Rich
Good
Ozer.
evening.
There's
Good evening.
Gerald. Gerald, you're not at the telescope.
We've redecorated the observatory
ah,
to look
yeah,
amazingly like my house.
yeah. And John Curry, he's in outer space.
Yeah.
And so, what we have tonight is not just the virtual telescope viewing that we usually have, but the virtual telescope viewing.
Yeah.
And because of our shelter at home requirements in Alameda County, and just being extra cautious, we are going to be doing our virtual telescope viewing virtually from home tonight. And it's also like 92% humidity, so we wouldn't be using the telescope anyway. So we have an
Yeah. I
opportunity
think it's
to.
going to rain later on too.
Yeah,
Also.
probably it's gonna rain, right? We don't want
Yeah.
the roof
Yeah.
open in the
Yeah.
rain.
Yeah.
So we have an opportunity to talk about the astronomy news of the week, show some excellent photographs that have been taken through Nellie and elsewhere, and answer your questions. We'll try to make it a fun program, even though we don't have the usual star of our show with us tonight, which is the telescope. And so bear with us, and hopefully we'll all learn something tonight. So, Gerald,
Yeah,
uh,
before we get started on some astronomy stuff, I just want to take care of a little business here.
yeah,
We want to make sure everybody is aware that Chabot, although our facility is closed to the public due to the pandemic, we are still operating. We are still doing programming, such as what you're watching now, and we still need your support. Obviously, because we're not open to the public, we're not getting the revenue that we would normally get. So, we're relying a lot more now on donations and financial support from the public. So, if you take a look up at the top of the Facebook page, you'll see a donate button. If you go to the Chabot Space and Science Center website, chabotspace.org, you'll see a donate button up at the top of the page there as well. Now, we have something special going on between now and the end of the month. And that is if you go to the Chabot website and sign up as a member, Chabot will match your membership with a free membership for a local teacher. So you get kind of a two for one. You get a membership and a local teacher gets a membership. So you might want to look into that as well. Regardless of how you do it, if you can help us out financially with some donations, we would really appreciate it. And also, if you work for a company that does philanthropy, that makes donations on behalf of employees or anything like that, you might want to talk to them and see if they can help us out as well. All right.
yep. Do you want to talk about the 21st?
Oh, yes. So, upcoming on the 21st, some of you may have heard that there's going to be a conjunction of Jupiter and Saturn. Some people are calling it the Christmas star because the two planets will be so close together that to the naked eye they will appear almost as one planet or one bright star. And that will be on the evening of the 21st. Jupiter and Saturn will be very low in the southwestern sky right after sunset. So we are planning to host a live virtual viewing of that event starting at 5 o'clock on Monday the 21st, 5 o'clock Pacific time on Monday the 21st, weather permitting. We will put a camera on the telescope and point it at Jupiter and Saturn. They will be so close together that both will fit in the same field of view of the telescope. So
Maybe,
that's really close.
Gerald, maybe you should define conjunction to people who may not know
Okay.
what that
All
term
right.
means.
All right. Well, conjunction is when two planets, in this case, two planets, come very close together from our point of view. The planets won't physically be close together, they'll be more than 400 million miles apart. But from our perspective, they will line up so that they appear to be very close together, almost touching each other. And so we call that a conjunction. Anytime two planets pass so close together that they are in the same part of the sky that we call that a conjunction. And this
Or
is
a planet and a star. It doesn't have to be two planets.
right, right.
No.
Um, And this is going to be a very unusual one. They're going to be unusually close together. This happens about every 20 years that Jupiter and Saturn get close together like this. But this time they're going to be unusually close together. And so we'll talk a lot more about that on the evening of the 21st, explain to you exactly what's going on, show you some diagrams, and so you can see what things like if you're outside the solar system, and explain it all to you. And so you want to join us on the 21st at 5 o'clock p.m. Pacific time. All right.
Now, speaking of conjunctions, we're big on conjunctions this month, because if you happen to be up early in the morning this morning, and you happen to be somewhere where there wasn't clouds, which wasn't
Actually,
anywhere around here,
Actually, it's
then
tomorrow night.
Venus and the moon
wrong conjunction.
yeah. Not to say no, it wasn't. It's
Yeah.
not tomorrow night. The Venus and the moon came very close. I have not seen many photographs of this. I've been searching all day, and I finally found one. In fact, if you want, let me see if I
We
can.
actually have a lot of celestial events going on.
Yeah, we have a sale on Christmas conjunctions.
I'm going to share my screen just real quick, because this is really nice, and let me know that if you guys can see it.
Yep.
Yes, we
Beautiful.
can.
Yeah, there we go. So the moon and Venus, and this is a photo captured in Slovakia. So this was kind of a worldwide event.
This is a very early morning event, right?
Yes, very early morning event. It has to be, because it's Venus. I didn't have to think too hard about that. That's the bright thing in the sky that I see when I wake up really early in the morning.
And not only that, look at the phase of the moon.
Yes, that too.
Must be very close to the sun.
All right.
Yep. So we're going to start.
Get cough out of the way there, and I think we're going to start
on the
Geminids, right?
Geminids, meteor shower. Mm-hmm.
So yet another upcoming celestial event. This will be tomorrow night, Sunday night, and into early Monday morning. We will have the Geminid meteor shower. Now, unfortunately, it's likely for people in the Bay Area, you're not going to be able to see too much because of the clouds and the rain that we've got going on right now. But if you happen to find yourself a dark sky location and you can actually see the sky, the Geminid meteor shower will start actually around 11 o'clock tomorrow night, the 14th, or the 13th rather, and continue well into the early morning of the 14th. So something to look forward to. And I've got a little, if I can share my screen here, I've got a little PowerPoint presentation to show you.
Yep. You should be able to
kind of explain what all's going on here. So, there are a number of meteor showers that happen every year. Some of them are not very prominent meteor showers. We have a couple, though, that are real humdingers. One is the Perseid meteor shower, which is in August, and the other is the Geminid meteor shower in December. So we normally associate meteor showers with comets. Comets are sometimes referred to as a dirty snowball because they're made out of a lot of ice, different types of ice. And embedded in all that ice is a lot of dirt and dust and gravel and pebbles and grains of sand and so forth, solid objects. And when a comet gets close to the sun, it goes through a process called sublimation. And that's where the ices in the comet convert to gases. And unlike the ice that you might find in your refrigerator, which melts and becomes liquid first, when ice sublimates, it goes directly from being solid to being gaseous. And when that happens, the comet forms a tail. And we typically see two tails on a comet. One is the gas tail, which is the remnant of the ice itself. That's ionized gases that are released by the comet. And the other tail is the particle tail. All that dirt and gravel and grains of sand and whatever that's embedded in the ice, as the ice sublimates, it is released. And the particles go into orbit around the sun. And what happens is, if that orbit happens to cross the Earth's orbit, such as you see here, it's possible for the Earth to pass through the stream of particles left behind by the comet. Now, this is just a two-dimensional view, so it looks like everything's flat, but the orientation of the comet's orbit is not necessarily on the same plane as the orbit of the Earth. But if one or both of the particle streams going around the sun happens to cross the Earth's orbit, and the Earth passes through that stream of particles, we see a comet. And when
we see a meteor shower.
A meteor shower. I'm sorry. Thank you. Keep me honest here. So we'll see a meteor shower. And what's happening is the Earth is moving along in its orbit at about 18 miles per second, and it passes through that stream. And it's kind of like when your car is driving through snow. The meteor shower appears to be coming toward us. And so this is kind of a graphic here. If we're moving straight into this image of the stars and we're moving into a meteor shower, the meteors appear to be coming at us from a central point. And that point we call the radiant. And it's actually the direction that the Earth is moving in its orbit around the sun. So we seem to be moving toward that part of space. We're actually orbiting around the sun. But for the brief period of the meteor shower, it appears that we're moving toward the radiant, which means the meteors that we're passing through appear to be coming at us from the radiant. So anyway, typically a comet is the source of a meteor shower. However, not always. So the Geminid meteor shower happens every year around the 13th or the 14th. Tomorrow night is the 13th, and it will last from about, like I say, about 11 o'clock tomorrow night, the 13th, into the early morning hours of the 14th. And again, it is one of the most active meteor showers during the year. The other really active one is the Perseids in August. We would expect on a really good night, if you're in a really dark location and there's no moon, you can expect to see 100 meteors per hour or more. So it's a very active meteor shower. Now, this meteor shower was known for a long time, but it wasn't until 1983 that the source was discovered. And it turned out that the source appeared to be not a comet, but an asteroid, which struck everybody as kind of strange. The asteroid is called 3200 Phaethon. And it has an orbit that is not on the plane of the Earth's orbit. It's tilted quite a bit to the plane of the Earth's orbit. It comes very close to the sun as it orbits around the sun. In fact, it gets closer to the sun than the planet Mercury. You see there that the distance, the perihelion distance, perihelion is the point when it's closest to the sun, is 0.14 astronomical units. An astronomical unit is the average distance between the Earth and the sun. So it's only 14% of the distance between the Earth and the sun, well inside Mercury's orbit. And because it passes so close to the sun, it gets pretty hot and it gets bombarded by a very strong solar wind, which also builds up a lot of static electrical charges on the surface. Now, it's possible that Phaethon is actually an old comet. It's very common for us to find that a lot of asteroids are in fact old comets that have lost all of the ices around their outside, and so they're just covered in a coating of rock and dirt and dust and everything. But interior, it still has a lot of that ice, and we think that's the case with Phaethon. And we think what's happening is when it gets close to the sun, that ice that's buried deep down starts to sublimate. You get the solar wind and the static electrical charges that cause especially pebbles and things to elevate off the surface of the asteroid, and that releases all these particles, but little or no gaseous tail. So this is an image of Phaethon. This is an actual set of images shot by our telescope up at the Chabot Space and Science Center. Some of you, I think, are aware that our biggest telescope, Nellie, is part of a global network of observatories that tracks near-Earth asteroids, and Phaethon is considered a near-Earth asteroid because although its orbit is tilted relative to the Earth's orbit, part of the orbit actually crosses the Earth's orbit, and that's why we get the meteor shower from the particles left behind by Phaethon. So this is just a series of images that we shot of Phaethon a couple of years ago, about the same time of the year, showing you moving across the sky. Okay, so Phaethon was discovered, like I said, in 1883 by the IRIS spacecraft, which was an early infrared space telescope.
So you don't mean 1883 then, you mean 1983.
Oh, yeah.
Well, that's when the spacecraft, they built the spacecraft out of wood.
Yeah, but Chabot was started in 18.
Yeah,
that may have something to do with it.
Chabot Space and Science Center was founded in 1883. I've got that number plugged into my head. So, yeah, it was discovered in 1983 by the IRIS spacecraft. This was the first time an asteroid was discovered by a spacecraft. Phaethon is about 5.1 kilometers in diameter, so it's a big asteroid, which makes it pretty easy to see. It's named after the sun god in Greek mythology. The sun god is Helios, and as I said, originally we thought it was an asteroid, but now we understand it to be the source of the Geminid meteor showers, and we consider it now to be a rock comet, sort of a half asteroid, half comet. There's kind of a misconception about asteroids and comets, as if they are two things, like a house and a car. And it turns out they're not. Comets and asteroids are sort of two ends of a continuum. So it is quite common for comets to eventually lose enough ice to where they convert into asteroids. And so it's not unusual for us to discover a lot of asteroids that have a lot of ice embedded in it because they're old dead comets. All right. I talked about the radiant a while ago in general, but this is the radiant specifically for the Geminid meteor showers. It's near the constellation Gemini, actually near the star Castor, which is one of the twins of Gemini. And as I said before, it peaks every year around the 13th or the 14th, and you can get up to 100 meteors per hour if you're in a really dark location. This kind of is a little misleading. It suggests that you should go out at night and look straight at the Gemini constellation to see them, and that's actually not the case. When meteors streak across the sky, they streak across huge parts of the sky at once, and it's only in that if you follow the line of the meteor back to where it seems to originate, they all seem to originate in the direction of the radiant. But meteors can actually appear anywhere in the night sky. So you don't want to stare at one point. You want to get outside and kind of find yourself a nice, comfortable place where you can lay down, spread out, and just look at large parts of the sky at a time. And you should see them. We got a little extra information here about observing the meteors. You don't want to use a telescope and you don't want to use binoculars. Like I said, a meteor streaks across very large parts of the sky at a time, and binoculars and telescopes look at only very small portions of the sky. So you are more likely to miss them than see them if you use either any kind of device other than your just naked eyes. Um, and again, you want to kind of get yourself a spot where you can look up at the sky and see large parts of the sky at a time, and kind of scan back and forth over the course of a half hour or so, and you should see several of them. Um, Midnight to 1 a.m. or 2 o'clock a.m., that's probably the best time. Obviously, if it's cloudy or foggy or hazy, you either won't see any or you'll only see the very brightest. And of course, if it's completely overcast, well, you're out of luck.
You're out of luck. Yeah, and once again, it's not tonight midnight to 2 a.m. It's tomorrow night midnight
yeah.
to 2 a.m.
Sunday night to Monday morning.
That's correct.
Right. All right. Okay. Well,
all right, I just want to give a
Thanks
quick shout out to Michael, who's viewing us tonight from Hong Kong. That's one of our more distant viewers. Thanks a lot, Michael.
Yeah, hopefully your weather's better than ours is. We've got not such good weather tonight. So, all right. Well, let's see what's next, Richard. Where do you want to go here? I got stuff about the Pleiades. I got stuff about M1.
Why don't we go to the opposite end of the spectrum and talk about M1?
Okay.
Because it's a prominent deep sky object this time of year. So
let me get an image up here. Hang on just a second, if I can find it. Here it is. And I'll share my screen here. Maybe. There you go.
Yep, that's working.
Yep. This is M1. It's what we call a nebula, and it is in the constellation Taurus the Bull, which is in the eastern sky right now. And M1 is the remnant of a supernova explosion, a very massive star that reached the end of its life and blew itself to smithereens. And now you've got all this material blown all over the sky. It's often called the Crab Nebula. I have never figured out why it's called the Crab Nebula, because it doesn't look anything like a crab to me, but that's what they call it. It's about 6,300 light years away. And this is the result of a supernova explosion. Now, it turns out supernova explosions are quite rare. They don't happen very often. Most stars do not die in supernova explosions. They die in a much slower process that results in a white dwarf and a planetary nebula. But the stars that are massive, more than 8 times the mass of the sun, those are the ones that will blow up as a supernova explosion and leave behind maybe a neutron star, and if there's enough mass there, a black hole at their center. So, Richard, you said you had
Yeah, I have a couple of things I want to show. Hold on, let me get these opened up. And
all right, I'll stop my share.
Give me a sec here. All right, I'm going to share my screen. So, not to upstage that photo from Nellie too much. This is another photo of M1. This is taken by Molly Wakeling, who is an EAS member, and she is a grad student at UC Berkeley, and she's becoming one of my favorite astrophotographers over the last year or two. She's really been upping her game, and this is something like, I don't know, it was like 30, 40 hours of exposure time total of M1. And
I just want to comment for a second, Richard. This is not something you'll see in a telescope live.
No.
If you're looking live through a
No.
telescope, you can just barely detect that it's there. You won't see
It
anything
looks like a
this.
little cloudy haze when you're looking
Right.
at it live through a
Yeah.
telescope.
Yeah.
And in order to capture this type of detail, not only do you need a lot of time, very very large number of 5 or 10 minute what are called subframes in the camera, but this one is also looking at light through what are called narrowband filters. So it's very specifically looking at gas that is glowing in the oxygen 3 spectrum or the hydrogen alpha spectrum. And you put it all together and you can come up with a very 3D image like this. And it looks a little more like a crab. I don't know. I've never seen a crab. I've seen crabs maybe run over by a car that look like this. Yeah, you're right. You're right though. It doesn't really look like a crab, but it is a remarkable object, and you could see the filaments really well in this particular picture. And that was the other point I wanted to make. These cataclysmic supernova events have a certain similarity among them. And this is another, whoops, wrong one, sorry. This is another, yeah, that was like, oh, wrong picture. I gave away my later picture.
You still got the wrong bit.
No, this is an object called Samis 147, which is another supernova remnant, and it's not terribly far in the sky from M1. It's near Taurus, near the border of Auriga and Taurus, if you know your constellations. This particular picture was the astronomy photograph of the day about a week ago. And the photographer was Georges Attard, European astrophotographer. And the reason I'm showing this is that you'll notice that those same types of filaments, that same quality in this photograph as you saw in the M1 photograph. So these types of huge events, when we get these supernovas, they tend to form the same types of remnants. And if you were to look through just a typical home telescope at this part of the sky, you wouldn't see anything, right? This is a very dim object, but it's huge. It's 3 degrees, and it means it's 6 times the size of the full moon. And so it covers a pretty fair amount of sky. And again, you need very lengthy exposure in order to see it, and certainly to pick out the color. So anyway, I thought that was worth showing the similarities of these of 2 of these things.
Hey, Richard, could you go back to the M1 picture for a second?
Sure. Let me actually see, go the right direction here. Yeah, there we go.
There you go. So one other thing I wanted to mention about this was a supernova that exploded in our own galaxy. And supernova explosions don't happen very often in any one galaxy. I think on average they happen about once every 100 years. This supernova occurred in the year 1054, and it was so bright that it could be seen on the Earth in the daytime. They were able to see it, and ancient astronomers actually recorded it, especially the Chinese recorded it quite a bit, that they saw, what appeared to be a new star and bright enough to be seen in the daytime. And it wasn't until years later that we realized that when we started seeing these faint fuzzies in the sky, that we realized that what we were seeing here, this supernova remnant, was actually a remnant of what was recorded back in 1054 as a new star, but actually was a supernova explosion bright enough to be seen in the daytime. So anyway, I just wanted to throw that in.
No, that's a good point. So that's getting me thinking here. How far away is M1?
It's 6,300 light years.
Okay, so Samis 147 is 3,000 light years away, and it's 40,000 years old. Right, so we're talking about twice the distance, but much older. So it makes me wonder what M1 is going to look like in another 30,000, 40,000 years.
Yeah.
And
Yeah. Really.
I guess I won't be around to photograph that, but but I wouldn't be surprised if it won't be covering a sizable part of the sky as well, although much dimmer, of course.
Okay.
Anyway.
Well, speaking of
Sorry.
galaxies and exploding stars and so on, I thought we could look at M31 if you're up for that.
Yep.
So let me hang on here just a second here. Find my way to M31. Oh, yeah, I just thumbed right past it. So I have a picture here that I want to share here. M31 is called the Andromeda Galaxy. It is the closest full-size galaxy to our own. It's 2.5 million light years away. It's a big spiral galaxy, very similar to our own galaxy. And often we're asked about, when we're up at Chabot and we actually have visitors up there and things, and we've got the big telescope going, people say, well, let's look at M31 with the big telescope. And it turns out that's not a very satisfying view. And I'm going to show you why here in just a second. So this is the view of M31 through our biggest telescope. Not very picturesque at all. And the reason for that is it's so big, we cannot photograph the entire galaxy in one field of view with a telescope. The best we can do is point it at one part of the galaxy. In this case, we're pointed at the central core, and take a picture of that part of it. And if we want to see the rest, we just have to kind of work our way around until we see the rest of them. So it's really kind of hard for us to see M31, as big as it is and as bright as it is and as close as it is. It's too much for our big telescope. You need a smaller telescope to view it,
or even just a camera on
yeah,
a telescope mount.
Right. So I'm going to stop that for a second, and then I've got one other image just to show you what the thing really looks like somewhere. Bear with me here. All right, here we go. So when you take a picture of M31 with a smaller telescope with a wider field of view, this is something like what you see. Very big, and the diameter, if you go to the full extent, even in this picture, you don't get the full extent of the Andromeda galaxy. Its size on the sky is 8 times the diameter of the full moon. So if you imagine going outside and looking at the full moon on the sky and then lining up 8 of those in a line, that's how wide Andromeda would appear to you if we could somehow turn up the brightness to where you could see it easily with the naked eye. It's a huge object on the sky. It's but far away and it's so faint that unless you're in a very, very dark sky location, you can't see it with your naked eye. But on the other hand, if we try to take pictures of it with our telescope, it's so big it extends beyond the field of view of the telescope. All right. Now, Richard, one of the things we've shown in the past at Chabot is globular clusters around the Milky Way galaxy. Globular clusters are like balls of stars that orbit around the galaxy in what we call the halo of the galaxy. And I understand that there are globular clusters around M31 as well.
That is correct. And I'm going to share my screen here just to give you an idea on how many have been identified. And there we go. So this is a photograph of Andromeda, and every one of these sets of white text here, they're all over. It's not is a separate globular cluster.
Can you zoom it a little bit?
I don't know if I can. It's hard to see, isn't it? Let me see if I get this. Here we go.
There you go.
That's better.
Yeah.
All right. So, I mean, one of the truths of astronomy and astrophysics is when you look at similar objects in the universe, they are similar not only in their macro appearance, but in their, smaller qualities as well. And so, we're in a spiral galaxy. We live in a spiral galaxy. Our spiral galaxy consists of stars and nebula and open clusters and globular clusters, and it has a central black hole. And when we look at other galaxies that are similar to the Milky Way, and Andromeda is, in many respects, very similar to the Milky Way. We find many of those same features, and there's something like, I don't know, but Gerald, what is it? About 400 or so globular clusters that have been identified in the Milky Way galaxy,
About
and
150 around the
or is it?
Milky Way galaxy, but a
Oh, I
lot.
thought it was larger than that.
No, there's
Okay,
a
so
lot more around M31. They've also
yeah,
counted over, I want to say 180 or so around M104, the sombrero.
got it.
Oh,
So here we are with hundreds of globular clusters identified, and obviously you wouldn't know that looking through a small telescope. They just look like individual stars here. But using more powerful instruments, you're able to uh, resolve that they're fuzzy objects, or look at other qualities like the spectrum of light and other aspects of it to know for certain that it's a globular cluster and not just a star. But again, it's the similarities between the Milky Way and Andromeda are more profound than the differences. And I thought that
When
would
you
be
look at this
interesting to
picture, you
point out.
also have to realize that the actual stars that you see in that picture are all in the Milky Way galaxy.
Yes,
They're
they're all
close to
foreground
us.
stars. That's
Yeah,
right. That's right. And the earlier image that Gerald showed from Nellie
same
is,
thing.
well, it's just was looking at a square just like this, right?
yeah, yeah,
About like so,
just
right?
very small.
None of this stuff was in that photograph.
Right, right, right.
All right, there we go.
Okay. Well, in addition to exploding stars and galaxies out there, there are several star clusters, and
I think we lost
there's one
Gerald
I
there.
wanted
There we
to
go.
start out with. It's not a picture from Chabot's telescope because, am I here? All right, hang
Yeah,
on
you were
just.
cutting out
On
at
and
least.
off.
Yeah, on and off. You were cutting out a little bit.
Okay, well, let me see what I can do here about. There we go.
Call
So,
Comcast.
yeah, how'd you know?
Yeah.
So let me
Just a
just
quick ad for
Yeah, yeah.
Comcast.
yeah. Let me just share this real fast. This is the Pleiades, and the Pleiades is what we call an open star cluster. It's a little less than 400 light years away from us. And these are all stars that formed at about the same time out of a huge cloud of gas and dust. And this is typical of how stars form. Stars form from condensing gas and dust in huge clouds. And those clouds form a lot of stars at the same time. And eventually, what happens is the gas dissipates and leaves behind several hundred stars to 1,000 stars that all form within it. The neat thing about the Pleiades is that you don't need binocular or telescope or binoculars to see it. This is a naked eye object. It's also in the constellation Taurus. And so if you go outside on a clear night and look up, and if you can find the Taurus constellation and you look at very carefully, you'll see a little sprinkling of stars, a very small sprinkling of stars. Some people mistake it for the Little Dipper, but it's actually in the wrong part of the sky for the Little Dipper, and it's much smaller than the Little Dipper is. It's the Pleiades star cluster. The Pleiades is the name given to some sisters in Greek mythology, so we often call this cluster the Seven Sisters. And in Japan, this cluster is called Subaru. And if you look at the emblem on a Subaru car, it's sort of roughly a graphic representation of the 5 brightest stars or 6 brightest stars. I can't remember which it is.
6.
6 brightest stars in the Pleiades star cluster.
The
So,
Subaru
again,
company was actually formed from 6 different companies, and that's why they picked 6 of the Pleiades stars.
And it's also the first automobile brand to use a Japanese word as its name. But you know what it means? You know what the word Subaru means, and that's got more of an astronomical bent to it. It means to gather together.
Oh.
Well, that definitely applies.
Yeah.
Now, these stars, like I say, they all formed at about the same time out of a huge cloud of gas and dust. So they're all roughly the same distance, 380, 390 light years away. And they're moving together through space. We were talking about globular star clusters a while ago. In a globular star cluster, the stars in the cluster orbit around the center of the cluster, and then the cluster orbits around the galaxy. With an open star cluster like this, the stars are not orbiting around some central point in the cluster. They're actually all moving around the galaxy as a group, kind of, if you can imagine, buckshot out of a shotgun, spraying out, all going in the same direction, and slowly separating apart as they move along.
And they're also in the plane of the galaxy like most of the stars.
Right. So if you imagine that they're orbiting around the galaxy, they're not all exactly the same distance from the center of the galaxy. And because of that, their orbital velocities around the center of the galaxy are not the same. The ones closer to the center orbit a little faster than the ones farther away from the center. And over time, that causes the stars in this cluster to slowly separate apart from each other, and eventually they will wander off and no longer appear to be all part of a cluster. This is very common. In fact, our sun was once a star in a star cluster like this, and that cluster has now spread out so much that we don't see ourselves as being in a cluster anymore. But that's how we started out, and that's how all stars begin their lives, in clusters like this. All right.
Yeah.
Mm-hmm. Now, I got another open star cluster that I wanted to do, and that's not it here. Where am I here? Let me stop this for a second and got all kinds of images here.
Or are you going to talk about M37?
M37, yeah. All right. So here is another open star cluster. This one is farther away, but it's appears to have a lot more stars in it. This is called M37. It's in the constellation Auriga, or some people call it Auriga. And it is a fairly tight cluster, open star cluster, almost 1,000 stars in it. And it is about 5,200 light years away. And it's very distinct. You point to your telescope at it, and it'll just fill the whole field of view of the telescope with just lots and lots of stars. Now, there is one star, and can you see my pointer?
Yes.
Okay, so right in the middle, you see it looks kind of red in this image. This was taken actually with one of our other telescopes, not with Nellie, but one of the other telescopes. So it looks a little red here, but when we look at it with a telescope, it actually looks more orange in color. And it's by far the brightest star in the cluster, except it's not in the cluster. It's actually farther away from the cluster than the stars in the cluster. It's just a much brighter star. It's a star that's actually beginning to reach the end of its life. It has swelled up, become a giant star, which gives it a lot more surface area to radiate light. And it actually kind of overwhelms all the other stars in the cluster, but it's actually not part of the cluster.
It does really stand out when you're looking at this through a telescope as well.
And it fools you into thinking it's part of the cluster, but it's actually not. It just happens to be along the same line. It's a conjunction.
Yeah, and yet another conjunction.
Yeah, there you go. All right. Okay.
Cool.
Well, where else should we go here? Let's see, where are we in time? Well, we got plenty of time here. So one other thing that I wanted to talk about, another really cool object that's in the night sky right now is the constellation Orion, Orion the Hunter. And Orion is really cool because it's one of the easiest constellations to find. And you're stealing my thunder there, John.
Sorry, I'm looking behind me here. Oh, no.
Yeah. John just got swallowed up by the constellation.
Yeah, well, actually, he got swallowed up by the nebula. So the Orion constellation is a very large constellation, and it has the most number of bright stars any constellation has in the night sky. So it really stands out. Plus, it's got 3 stars that are nice spaced in nice even row. We call the belt of Orion. So it's a really easy object to find naked eye. And if you look at the sword of Orion, the sword of Orion looks like 3 faint stars all lined up. And if you look carefully, the middle of those 3 stars looks sort of fuzzy. And when you look with a pair of binoculars, and definitely with a pair of, or with a telescope, you see it's not a single star at all. It's a bunch of stars surrounded by a huge cloud of gas and dust. And you see an example right behind John's head there. That is an image of, let me see if I can pull mine up here, John. So I don't force you to
duck.
Yeah.
Yeah. So here you go. This is one of the many images that we have here. Here you see the Great Orion Nebula. And this was taken with our big 36-inch telescope. It's a relatively short exposure. And what you see are 4 very bright stars at the center. We call this the trapezium. These are very young stars that formed out of this huge cloud of gas and dust. And the trapezium stars are massive stars, so they are extremely hot. And they're emitting a lot of radiation, including ultraviolet radiation. And that radiation is actually pushing the cloud away from the stars. And so it's created a pocket within the cloud that you see here. Now, the light from those stars is reflecting off of some of the cloud, but the ultraviolet radiation that's being emitted by those stars is also ionizing the cloud, and ionized gas glows. So we see both what we call an emission nebula and a reflection nebula at the same time. Gas that's glowing because it's being ionized by ultraviolet radiation, and reflected light off the gas from the light of those very young stars in the trapezium. So this is a really easy object to see with binoculars, and even in a small telescope, it just reveals a whole lot. Looking with the small telescope at this is the center of the sword of Orion. Now, one of the difficulties with taking pictures of it, the reason you're not seeing a whole lot of detail here, is that in order to see the trapezium stars as individual stars, we have to use a very short exposure. But using a short exposure means we don't see as much of the gas cloud. The gas cloud actually extends quite a ways. And I'm going to see if I can find another picture. Here we go. So using the finder on our big telescope, well, this is a wider field of view. And in this picture, we've done a longer exposure to see more of the gas cloud. But in doing so, the central part here, where those 4 stars gets completely saturated. It's that those stars are just so bright that they will saturate your image if you try to take a longer exposure. But the only way you can really see the full extent of the gas cloud, and even this is not the full extent of it, but gives you a much better sense of all that gas and dust that surrounds the trapezium. And this gas cloud is condensing and forming new stars. Several years ago, the Hubble Space Telescope took a picture of this. They actually took a bunch of pictures and made a mosaic so you could see the whole thing. And they created a very high resolution image. I think it was 78 megabytes or something like that. And what was really cool is once you waited the hour it took to download the thing, you could zoom in and zoom in and zoom in and see more and more and more detail, to the point where you could actually see the little um, um, globules of gas and dust surrounding very low mass stars that were still in the process of forming, the gas was still forming a cocoon around these very young stars that were embedded within this cloud, just hundreds of them in there. So this is the Orion Nebula, and it is one of the great things to try photographing. I would wager that just about every astrophotographer out there, this was one of the first things they tried to take a picture of, because it's easy to see, it's easy to find, and it doesn't take a whole lot of skill to get a reasonably good picture of the Orion Nebula.
Gerald and Richard, too, isn't there a website that has that that mosaic where you can zoom in on it?
I have seen it, and I've been looking for it, and I can't. I haven't found it yet.
Probably the Space Telescope Institute might have one.
Actually, I think Richard, you emailed me. Let me see if I can find that. Go ahead and keep going.
Oh, okay, I was going to mention that the first written observation of the Orion Nebula was in 1610. So that was the first time somebody saw it and wrote and actually wrote down that they saw it. So
yeah, and the telescopes were only in use for about 10 years at that time. So that's pretty cool.
Yep.
Right. Okay, so this is what we call a nebula. Nebula is a word that just means cloud, and there are several different kinds of clouds out in space. There are clouds that are condensing to form new stars. There are clouds like M1 that are the remnants of exploding stars. There are clouds of gas and dust that are just drifting through space. We're not sure where they came from. But the word nebula is always applied to a cloud out in space. There's another cloud out in space that I wanted to show you. I'm going to show you an image taken by our big telescope at Chabot. And bear with me here for a second while I find it. There we go. So this cloud is what we call a planetary nebula. And the one we're going to be looking at is called the Clown Face Nebula. We used to call it the Eskimo Nebula, but recently there's been a decision to not use that term anymore for this nebula. So we just call it the Clown Face Nebula. This is what we call a planetary nebula. It is also the remnant of a dying star, but it's not a supernova explosion. This is a star that dies under the more typical process of a slow death, resulting in a huge cloud of gas and dust surrounding what's called a white dwarf. And a white dwarf is very small. It's maybe the size of the planet Earth, but it has the mass of nearly an entire sun. So a white dwarf is extremely dense, and it is extremely hot, and it emits a lot of radiation as ultraviolet radiation. And it's the remnant of a star that was once similar in size to our sun. When stars get really old, they swell up. They become giant stars. As they swell up, the outer surface of the star cools, and the gravitational pull on the outer surface weakens because it's so big. And at the same time, you've got some pretty strong winds being generated internally in the star. And so the star starts blowing its outer layers of gas off into space. And it does that for several tens of thousands of years, 100,000 years or so, during which time it loses quite a bit of its mass. It can easily lose half its mass or more, blowing out into space over thousands of years. Eventually, what's left of the star collapses and becomes that white dwarf. And the white dwarf is surrounded by all that gas. The white dwarf is emitting ultraviolet radiation, which ionizes the gas and causes it to glow. So what you see here is the glowing shell of gas around the white dwarf. Now, the white part in the center is not the white dwarf. That's actually a much denser part of the gas cloud where there are some shock waves working their way through the dense cloud and makes it shine like that. In this image, it looks white. In a lot of images, it looks kind of orangish red in color, kind of like a clown's nose, which is where the term clown face nebula came from. So the white dwarf is actually in the center. It's almost impossible to see unless you've got a very high resolution telescope and you zoom way in on it. There are some great Hubble Space Telescope images of this that are very colorful, and in those you can see the white dwarf. But this is typical of how stars like our sun end their lives. And this is a preview of what will happen to our sun in about 5 or 6 billion years. All right. This is called the Clown Face Nebula. It's also called NGC 2392. It's about 612 light years away. And Richard, I think you said you had a little video tour of it.
Yeah,
right?
I do have a video tour that was produced by the Chandra Space Telescope team. It lasts for a couple of minutes. I thought I could show that.
All right. Chandra's an X-ray telescope, right?
While you're
yes.
getting
And,
that, I just want to mention
that
I found that Orion mosaic, and I posted the link in the comments.
Oh yeah, okay, I see that. Yeah.
All right, let's see if this works.
It's a big file, so if you download it, be forewarned. It's
yeah. Don't plan to do anything else for a bit. All right. Yeah, the reason Chandra was interested is that this planetary nebula is an X-ray source. Chandra is an X-ray telescope,
right.
And they're able to detect quite a bit of X-rays off to the side of the white dwarf star, where there's a lot of hot plasma. Anyway, let me see if I can get this to work. You guys should see a Google Chrome browser there. Is that what you see?
Yep.
All right. Let's see if this works.
There's a Hubble Space Telescope image, Has it got sound?
It's supposed to have sound. We'll see what happens. Here we go.
You may have your speaker muted there.
Yeah, it may not let me do this because
when you click on the share button,
there we go. I gotta unmute.
4,200 light
years. Let's try this again. Here we go.
Stars like the sun can become remarkably photogenic at the end of their lives. A good example is NGC 2392, which is located about 4,200 light years from Earth. NGC 2392, which is nicknamed the Eskimo Nebula, is what astronomers call a planetary nebula. This name, however, is deceiving because planetary nebulas actually have nothing to do with planets. The term is simply a historic relic, since these objects looked like planetary disks to astronomers in earlier times looking through small optical telescopes. Instead, planetary nebulas form when a sun-like star uses up all of the hydrogen in its core, which our sun will in about 5 billion years. When this happens, the star begins to cool and expand, increasing its radius by tens to hundreds of times its original size. Eventually, the outer layers of the star are swept away by a slow and thick wind, leaving behind a hot core. This hot core has a surface temperature of about 50,000 degrees Celsius and is ejecting its outer layers in a fast wind traveling 6 million kilometers per hour. The radiation from the hot star and the interaction of its fast wind with the slower wind creates the complex and filamentary shell of a planetary nebula. Eventually, the central star will collapse to form a white dwarf star. X-ray data from NASA's Chandra X-ray Observatory show the location of million-degree gas near the center of NGC 2392. Data from the Hubble Space Telescope reveal the intricate pattern of the outer layers of the star that have been ejected. Taken together, these data from today's space-based telescopes provide us with the spectacular views of planetary nebulas that our scientific ancestors, those who thought these objects were associated with planets, probably could never have imagined.
Right.
Cool.
Yeah. All right. Million degree.
Yeah.
That's
So-
hot.
Yeah.
So when you saw the image there, that was a Hubble Space Telescope image of it, and you may have noticed that it has kind of a reddish-orange blob right in the center, and that's the clown's nose. So we call it the Clown Face Nebula now. All right.
Yeah.
Well, let's see. I think I've run out of objects.
Yeah,
Well,
it's 10
we're
o'clock,
also almost
too.
out of
Yeah.
time here.
Oh,
Yeah,
well,
we're
okay.
right there at 10.
Okay.
So I thought considering that this is a double virtual presentation tonight, we covered a lot of ground. Did pretty well.
Yeah.
So we have time to take questions from people. Really, anything you got, and we're watching both Facebook and our guests who are on YouTube.
And while you're writing all those questions, and if you think it's a stupid question, those are our favorite kind of questions to answer. So please write those stupid questions, okay? But while you're doing that, I want to remind you again that we are looking for your support. The Chabot Space and Science Center is a nonprofit, and during the pandemic shutdown, we are having a lot of trouble generating revenue. And we are still in operation as far as generating virtual programming. We do a lot of virtual programming for students during the week, programs for scouts, and of course, what you're watching now. And we are planning to reopen as soon as the pandemic is open, probably sometime next year. And we want to be able to hit the ground running, of course, when that time comes. So we do need your support. So if you can click on that donate button up at the top of the Facebook page, or if you want to go to the Chabot Space and Science Center website, it's chabotspace.org. And you'll see a donate button up at the top of the page. And then again, we have our matching program this month, where if you sign up for a Chabot membership, Chabot will provide a free membership to a local teacher. So you get a 2-for-1 program for that. Also, I want to remind you about next week. We will do this again at 9 o'clock next week. We will still be under the stay-at-home order for Alameda County, so we will probably end up doing it again as a virtual event from home. And then once the stay-at-home order is lifted, we'll be back to doing it up in the observatories. But we have made special arrangements so that we can do a program from the observatory on Monday night, the 21st, for the conjunction of Jupiter and Saturn. And that will start at 5:00 p.m. Pacific time on Monday, the 21st of December. So you will get to see it through the telescope, weather permitting.
Yeah, cross your fingers that we get good weather that night.
Always weather permitting. All right. So how are we doing on questions?
Well, you answered the only one that I see so far.
Yeah, I don't see
as
any
part of
on
your
YouTube
description,
either.
it was just a question about our shelter in place.
Oh, okay.
So you
Yeah.
got that.
Yeah. So yeah,
Right.
so what you'll see if you tune in to us on Monday night, if you've been watching us in the past when we do the virtual programming, you see us. We're all in the same building, although we're separated from each other by quite a bit. In order to comply with the stay-at-home order that we're currently operating under, we had to do it very differently. So we'll be up there and we will be running the telescope, but you won't see all of us in the same room. We will actually be in different parts of the facility so that we are very far away from each other. And so that allows us to, protect each other from that nasty bug out there. All right.
Well, I think that's it. I'm not seeing many questions tonight. And
Yeah, a lot of comments, not too many questions.
Oh, here was one. Are there any young nebulas out there? Yes, of course. Nebulas are emerging all of the time. Particularly planetary nebulas. So there are some that are only, hundreds or thousands of years old, and there are others that are, tens of thousands or millions of years old. And the universe is a very dynamic place. So the answer is yes.
Yeah, one of the things about the planetary nebula that you saw, they don't last forever. They slowly dissipate, and eventually the gas drifts off and you don't see the planetary nebula anymore. But that takes thousands and thousands of years. So,
All right.
okay.
All right. Well, thank you all for joining us tonight. And sorry we couldn't have the telescope with us, but it doesn't fit into my office upstairs. And we'll just have to pay it a visit when the sheltered place is over. But I hope you join us next week, and I hope you join us on the 21st. Have a good weekend and
one other thing
a good week. What you got, Gerald?
One other thing we should note, we will be doing this next week at 9:00 p.m. Saturday, next week, the 19th. However, the 26th, the day after Christmas, we are not going to be doing this. We're actually going to take a weekend off. So, but we'll be back the following weekend, and hopefully not too long after that, the stay-at-home order is going to get lifted, and we'll be back up at the telescope again.
Oh, we hope so.
Yeah.
All right.
All right.
Well, good night, guys.
Okay. Good night, everybody. Good night,
all right.
everybody.
You have a good weekend. Bye-bye. Okay, I've ended the stream.